let's continue along looking at, again, more problems where we're going to be told to factor. Now, they actually say factor out the greatest common factor. We're just going to be told in most problems to factor, so let's just get used to that. So the idea is figuring out what do our terms have in common first. Well, if you look at this first one on the next page, we've got a 4x squared and a 12x. Well, first of all, if I just look at the 4 and the 12, they're both divisible by, if I just look at the 4 and the 12, they're both divisible by 4. So I can factor out a 4 to begin with. Also, what do I notice is, so I will pull out my 4, but I also notice if I look at the x's, I've got an x squared and an x. That means both terms have at least one x in them, so I can pull out at least one x from each and every piece. Then my leftovers, whatever's left over, is going to go inside of a little set of parentheses to save for later. So now what this means is out of each and every piece, I'm going to be pulling out a 4 and 1x and seeing what's left. So the first piece had a 4 and 2 x's. So if I only pull out the 4 and 1x, I'll still have an x left over. I'll carry down the plus. Dividing out or pulling out the 4 from the 12 will leave me with a 3. And pulling out the x will mean that the x with the 12x will actually just completely vanish. And if I wanted to double check this, I could distribute the 4x back out and also make sure that these two pieces have nothing in common because you're supposed to factor out the greatest common factor. But as long as they don't have anything in common, you've gotten everything you can and you're all done. So we are factored and that is our final answer. And problem B, we don't have any numbers in both terms to look at to see what they have in common, but if we look at the x cubed and the x squared, the first term has 3 x's, the second term has 2 x's. So at most, I can pull out 2 x's from each piece. So that's going to be our greatest common factor is x squared. Whatever's left over from each piece will go inside of my parentheses to save for later. So let's take a look. If the first piece had 3 x's and I take out 2, I've still got an x left over. Plus, let's carry down the plus. The second piece had a 3x squared. So if I pull out the x squared, the 2 x's, I still have a 3. Again, I always do a quick double check that the terms that are inside have nothing in common to make sure I've gotten the greatest common factor. You can also distribute the x squared just to make sure it matches up with what you had originally, but we are all done. That is considered completely factored and done. Let's take a look at C. If we look at C, let's take a look at the 30 and the 12 first. Both 30 and 12 are both divisible by 6, so I can factor out a 6. Factor out or divide out a 6 first. Then I can look at my x's. The first one has an x and the second one has an x squared. So I can only pull out one x from each piece. Now let's look at the y's. Well, the y's, I've got a y to the 4th and a y to the 3rd. So I can pull out at most 3 y's from both of the terms. And then my leftovers will go inside a set of parentheses to save for later. So let's see what happens. Well, if I divide out the 6 first from the 30, I'll end up with a 5. Dividing out the x means the x will be gone. And then dividing out the 3 y's from the 30x y to the 4th. Well, it had 4 y's. If I take out 3, I've still got a y left. Let's carry down the minus next. Now 6 dividing into the 12 would leave us with a 2 on the second term. But here's the problem. We're only going to pull out one x out of the 2, so I'll still have an x left over. Now I'm going to pull out 3 y's. Well, if I pull out 3 y's, then they're all gone, and I'll just have the 2 and the x left. And that's it. So I've got 6xy cubed times, in parentheses, the 5y minus 2x. And again, just double check that the 5y and the 2x don't have anything in common to make sure you got your greatest common factor. If they do somehow have something in common where they still have an x or they're still divisible by 2, it means you just didn't get everything out that you could have, so you just have to start over again. Let's try another one. Let's look at D. Let's look at the numbers first. We have a 20, a 15, and a 10. They're all divisible by 5, so I can factor out a 5. Okay, now let's look at the m's. M cubed, m squared. So at least, all 3 of these terms have at least 2 m's, so I can pull out an m squared. Now let's look at the n's. We've got an n cubed, an n squared, and an n. So each of these terms have at least one n. So I can only pull out one n, and then let's see what's left over when we pull out what's in common. Notice we're pulling anything that we pull out now is pulling out of all 3 terms, not just out of 2. So we've got to be careful. So pulling out the 5 from the 20 first will leave me with a 4. Pulling out 2 m's from the 3 still leaves me with an m. Pulling out only one n from the 3 leaves me with 2 n's. Carrying down the minus next. Now dividing out the 5 from the next piece turns the 15 into a 3. Pulling out the 2 m's will turn the m cubed into an m. Pulling out only one of the 2 n's still leaves me with an n. Carrying down the, looks like a plus that I wrote over. And let's see, was it a plus? And then the next one, pulling out the 5 from the 10 is a 2. Pulling out 2 m's means they'll both be gone. Pulling out one n means the one n I had will be gone. So I'll be done, and that will be my final answer. And again, notice that if you look at all 3 terms that are left over, they don't have anything in common. So I do know I pulled out the greatest common factor and I got everything